Welcome to the Sun today for the 17th of February 2022. This is about sun-diving comets, or what I like to call them, Kamikaze comets. Kamikaze means heavenly wind. In a sense, the comets look like they do because of their interaction with the solar wind. And so there's nothing more heavenly than the solar wind. Here is today's quick summary of what's going on the Sun that I posted on my Twitter channel this morning. In panel 1, I show the NCDC sunspot number, which is at 88 at the moment. You can see for most of the month it's been at a very high level. In panel 2, we have the KP index, which is a measure of the stability of the magnetosphere, and you see things are relatively quiet at the moment. And first thing this morning, the solar wind was at 335 kilometers per second. In panel 3 shows the actual sunspots on the Sun. I've upgraded this somewhat by color coding the sunspot groups. If a region is decaying, I mark it with red dots. If a region is newly emerging, I mark it with white dashes. If the region is stable, it's just a black circle. But regions that have been there on previous days but are now growing are marked with green. You can see we've had 3 new regions emerge in the last 24 hours. Now these are fairly weak and small regions, so I don't know whether they will survive very long, with the exception of the one in the southeast, the bottom left, and was actually numbered active region 2952 earlier this evening. It's been 68 days since we've had a spotless day on the Sun, and we've been 24 consecutive days with a flare greater than C1, and in panel 4 you can see that it's been fairly quiet this last 24 hours. In fact, we only just had a C flare right at the end of yesterday to keep that string going. We've had 3 small C flares today, but nothing really spectacular like the M1.3 that we had a couple of days ago. So things are relatively quiet and stable, and nothing too spectacular is going on, with the exception of these 2 comets that are crashing into the Sun. So let's talk about those. There is a class of comets called Kreutz comets, I think I'm pronouncing that correctly, which are sun divers. Their origin seems to be that a large comet broke up many centuries ago, and these are the remnants of that comet. These remnants flow along the original comet's orbit, sometimes getting perturbed by planets, and pass close to the Sun, but they have a perihelion, the furthest distance from the Sun, of about 170 astronomical units. They are 170 times further away from the Sun than the Earth is. Most are too small to survive perihelion. You've got to either be large, so you can afford to lose some of your ice as you come close to the Sun, or you have to be moving very, very fast to get past the Sun before it destroys you. And most of these comets don't meet either of those criteria. One that did, that you may remember, was Comet Lovejoy. It was a member of this series. SOHO was launched in 1995, so has been observing these objects for 26 years and has found thousands of them. Here are just a few of the more spectacular examples that we've seen over the years. So the story for today is that we've seen 2 comets simultaneously diving towards the Sun. The largest piece we saw first was detected at the edge of the SOHO-LASCO C3 field of view. That's the large low resolution field of view. That was the large low resolution field of view. It was first seen at 1604 UT on the 15th of February. It's that little faint dot in the middle of that circle. The smaller part, which we'll see later, was not visible at that point. The last view we got of it was from the LASCO C2 field of view. That's a high resolution field of view near the surface of the Sun. I had to play around with the color tables, the exposure times, and the database to get this picture, and it's very faint, so look carefully here. That streak that you're seeing coming in from the eastern side of the Sun is the last remnants of that comet that was coming in. That's probably, again, the larger piece. Taking the full flight of that comet, assuming it's just in the plane of the sky, which is a poor assumption, implies a velocity of over 100 kilometers per second. That's on average. And when you first see it, it was probably moving much slower than that. As it got very close to the Sun, it was probably moving much, much faster. So of course we're going to look at a movie of this, and this is what you expect to see. You'll see the sun in the top right-hand corner in the dark circle, and these two objects, one faint, slightly leading, and one much brighter following, going towards the sun, starting at about 7:30 on the clock dial and going into the sun. So as I said, we're going to use the LASCO C3 field of view here and make a movie out of it. And this time we're just concentrating on the comets, not on the coronal mass ejections. I'm going to give you 3 repeats so you have a good chance to follow the trajectory. And you can always stop the video and go back and look at it more times if you wish. So what conclusions can we draw from all of this? Well, first of all, because of the trajectory of these comets, they were certainly a member of the Kreutz series. They were probably one time a single piece of comet and broke up as they started to approach the sun, and we're seeing them after that breakup because they're close together spatially and on pretty much the same orbit. Neither of them survived perihelion. I looked for signs that they were coming out the other side and saw none. They were also fairly small, so that's not usual that they would survive such a close passage with the sun if they're that small. The streak that we see is probably not the comet itself, but the dust and the pebbles from the remnants of the comet being vaporized by the solar radiation as it gets close to the sun. It will then be picked up as plasma and blown away in the solar wind. And that's it for today. Until next time, be safe and goodbye.